So this part of our task today is probably the most, I don't say difficult, but the part that requires the most thinking. So this is actually a task from the Exemplars Library that I got when I was an employee of Region 6. So it's a very good problem. It's comprehensive of volume and just general realistic problem solving. So 3 Little Pig builders have gone into the prefabricated home construction business, building houses, building the 4 homes shown below. They've decided to charge $25,000 for the silo-shaped home, so they have to figure out what's the fair market value for each of the other homes if they are proportionally based on the value of the silo. So that requires us to do a couple different things. So the first thing we have to do is find the volume of the silo. And if you don't know what a silo is, the silo is this one. And it even tells you it's got a cylinder and a hemisphere. So we have to find the volume of the silo first. And then we have to figure out the fair market value, which basically means we have to figure out the cost per feet cubed. So we're going to divide the $25,000 they're going to charge for this house by feet cubed. All right. Now I'm not going to do this part for you because this is the fun part. But what I will do is do a similar example. That way you can follow the example and apply it to this problem. So let's get a similar house up here. So let's just say we've got, I don't know, I'll do a cone-shaped house because that's pretty fun. I'll do a house with a cylinder bottom, and then I'll do a cone shape on top. It's kind of like Luna Lovegood's house in Harry Potter. So let's say this is my house. They're going to charge $25,000 for this house. Let's just say. Now notice, this is not going to be the fair market value you see on your page. It's not going to be the volume you see. This is just the process. All right, so I'm going to cover the other paper just so you don't think it's the same thing. So this shape, we have a cone and we have a cylinder. And let's see, I think a reasonable cost, or not a reasonable cost, I think of reasonable dimensions. Let's say that this cylinder is like 30 feet wide. Now notice, these houses are a lot smaller, 5 feet wide. So we'll probably get a much different answer than you will on the other paper. So 30 feet wide. And let's just say the cylinder itself is like 9-foot ceilings are pretty reasonable. Then let's say the cone up here has a height of like, I don't know, maybe there's 2 floors up there, go with like 20 feet. So you have to find the volume of the cone and add it to the volume of the cylinder. I'm trying to write a little bit bigger today because some of you mentioned that it was a little bit hard to see. I'll also see if I can do something about the mild shake because the phone's resting, but I'm still holding it, so it's a little shaky. So cone plus cylinder. So if you have your formula sheets out, you should pause this and try to do it on your own before I do it for you. So pause it now, give it a try. So my cone formula, pi r squared height over 3. Remember, it's radius, not diameter. And my cylinder is pi r squared height. Now keep in mind, there's 2 different heights because the cone and the cylinder have different heights. So cone is pi, the radius is 15. Same radius as the cylinder, height is 20. Now that 30 feet is the diameter. So my radius is 30 divided by 2, which is 15. All right, so pi times 15 squared times 20 divided by 3, because 3 cones fill a cylinder, and then plus pi times the radius is still 15, and the height of my cylinder is only 9. All right, so we'll do this in terms of pi first, just for kicks. Let's see, 225 times 20 is 4,500 divided by 3, 1,500 pi. That sounds about right. And then 15 squared times 9, oh geez, okay, 225 times 9. Well, 225 times 10 is 2,250 minus 225. Oh, is it 2,025? That sounds about right too. I'm gonna check all these, because I don't want to be wrong 5 minutes into a video. That'd be awkward. Let's see. Yep, 2,025 pi, and 225 times 20 divided by 3. Yes, awesome, cool, so my math's right. So then, I could leave it in terms of pi and get 3,525 pi feet cubed. Or I could say that's, well, just multiply by pi. 3,525 times pi. 11,074 cubic feet. Okay, so we figured out the volume. That was step 1. Step 2 is to find the fair market value. So we want to find the price per, sounds like a slope to me, or a constant of proportionality, price per foot cubed. So we have to divide the $25,000 times 11,074 feet cubed. And we're gonna get some terrible decimal here, I'm very sorry, kind of. Let's see, 25,000 divided by 11,074. I rounded that, yeah, it's 0.11, but it's not gonna make much of a difference. 2.26. So it's about $2.26 per cubic foot. It seems fairly inaccurate, but keep in mind, I took the $25,000 from a much smaller house. So then, once I have my price per square foot, I'm going to use that later. So when I find the volume of my next house, I'm going to use this to find my fair market value. So I'm going to give you one more house. Let's see, I'll make this one easier. I'll make this one just like, let's see. They've got a silo, they've got a cone, they've got a rectangular prism, they got everything on this paper. Let's just live in a pineapple. Okay. So we've got, this house is a cylinder on bottom. That's a terrible cylinder, I'm very sorry. And a hemisphere. Okay. So we got cylinder and hemisphere. So again, we're going to find volume. And then we're going to have to use $2.26 per square foot to find the fair market value. All right, let's give us some nice friendly numbers. Let's just give us multiples of 3 and 2 are always niceness. I'll just say this is 12 feet And I'll just say that my diameter is, let's just say it's also 12 feet. SpongeBob lives in a cubic, very cube-like pineapple. Okay, 12 feet tall, 12 feet in diameter. So that means my radius is actually 6, because remember, in realistic situations, no one really talks about radius, because why would they? So hemisphere is, let's see, I'm gonna use my, I'll use my regular hemisphere formula, 2/3 pi r cubed plus pi r squared height. So I got 2/3 times pi times my radius is 6 cubed, pi times radius squared times height. All right, let's see if I can do this in my head. No, let's not. All right, so we got 36 times 12 is 432 pi. And then over here I got, let's see, 6 cubed is 216. Divide that by 3 is 72, times 2 is 144 pi. So I've got 576 pi, which is just something around 1800 or something. Oops, that was the wrong button. $1809.56. It's a little bit more than tripling it. All right, so we have that as our cubic feet. So now there's my volume and there's my price per square foot. So now I want to take these two final pieces and multiply them. Yes, because it's $2.25 per square foot. So 1809.56 times that cost per square foot. And that will get me another atrocious decimal. I know, you all hate decimals, I do too. But the real world is full of them. It's all just a guessing game, really. And that gives us 4,089.599 rounds to 60. So $4,089. And this house is a lot smaller than our Luna Love good-shaped house up top with the hemisphere and the cone. It's a lot less wide. And remember we talked about earlier, radius affects volume a lot more than height does. So we should expect this house to cost a lot less, because that house cost $25,000. It's clearly a lot bigger, and this house cost $18,000. So that's what you're gonna have to do. Now keep in mind, none of these numbers are the right ones for your paper. It's not $226 per square foot. This isn't the house on your paper. That's not the silo. This isn't on your paper. This is your guided, this is like your classwork before the actual thing. All right? So give that your best try. If you can do this problem, you are prepared for many problem-solving things in this unit. So good luck.